Hello everyone, welcome to Pay1 Tech video. This video is another example of route summarization or route aggregation. Let's say a company has multiple subnetworks of 172.16.43.0 with the silo notation of 24, another subnet 172.16.44.0 silo notation of 24, another subnet 172.16.45.0 and another one 46.0 with the side notation 24, another 172.16.47.0 side notation 24. So instead of having 1, 2, 3, 4, 5 different network addresses in the routing table, so the router has to advertise all these addresses, we can have only one address, and advertising that one address can include all these addresses. That's known as router aggregation, IP address aggregation, or supernetting. So what we have to do first, we have to look at the octet that are not the same. So 172, that's all the same. 16, and so on, all the same. This octet, 43, 44, 45, 46, 47, not the same. And the next step, we need to convert it to the binary. So let's say we write it 172, 16, and 43 needs to be converted in binary. And then let's write down. Okay, so if I write down the here on a third octet 8 bits, right? So 1, 2, 3, 4, 5, 6, 7, 8. And decimal values of the octets, we already know 1, 2, 4, 8, 16, 32, 64, 128. So for 43, which one do we have to turn on to get 43? This one is off, 32, this one is off, this one is on, 32 plus 8, that's 40, this one off, on. So 32 plus 8, that's 40, plus 2, 42, plus 1, 43. So this is the binary for the 43. I'm going to write it down here. So we have 0, 0, 1, 0, 1, 0, 1, 1, and of course 8 zeros here. 1, 2, 3, 4, 5, 6, 7, 8. Now let's erase and move on to the next one, and the next one is 44. So which one do we have to turn on? So we know this is off, this one is on, off, this one is on, that's 40, and this one is on, 44. So that's it. Let's write down 0, 0, 1, 0, 1, 1, 0, 0, and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Let's move on to the next one. Next one is 45. So this one is off, on, that's 40, 45. So is this 2. So 32 plus 8, that's 40, plus 4, 44, plus 1, 45. Let's write down here. So 45 on a third octet. Here I am on a third octet. Let's write down the binary. 0, 0, 1, 0, 1, 1, 0, 1. And 8 zeros for the last octet here. So 1, 2, 3, 4, 5, 6, 7, 8. Let's move on. So the next one is 46. And for 46, it's basically 4 and 2, right? So this one is off, on, 32 plus 8, that's 40, 46, which is 0. So 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. And then 8 zeros. And if we continue on the next one is 47. So 47 is this one, And this one, that's 40, 44, 5, 6, 7. So let's write down the binary here. 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 1. And 8 zeros because of the last octet. Okay, so that was the first step, converting the octets that are not the same into the binary. Then we have to count how many of those bits are exactly the same. We know 72, 72, that's all exactly the same. 16, 16, 16, all the bits exactly the same in an 8 octet, right? Because all of them is 16, so it's exactly the same. Here, let's count the first bit. Looking at the first bit on a third octet here, 0, 0, 0, 0, 0. Very good. So this is matched. So it's on. This one, 0, 0, 0, 0, 0. So that's on. 1, 1, 1, 1, 1. That's all matched, right? So that's on. 0, 0, 0, 0, 0. On a fourth bit, right? That's on. And then 1, 1, 1, 1, 1. Very good. On. So that was the fifth bit, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the sixth bit, this is 1, 1, 1, 1, 0. So that's not matched. Therefore, that's off. And after that, all the bits off. Okay, and here we know on the first octet, 8 bits are exactly the same, right? 172, 172, right? So all the 8 bits are exactly identical. 1, 2, 3, 4, 5, 6, 7, 8. And then here for the 16, all 16. So all the 8 bits are exactly the same. 1, 2, 3, 4, 5, 6, 7, 8. And here we just had to find out how many bits are exactly the same, which only the first 5 bits were exactly the same. And after that, when we get to the first bit that's not the same, after that we put 0. Okay, so here is our cut line. And if we count all the ones, 8 plus 8, that's 16, 17, 18, 19, 20, 21. Therefore, the new CIDR notation is 21. Now we need to find the network increments. So where is the cut line? On a third octet. If we write down the decimal values on a third octet, 1, 2, 4, 8, 16, 32, 64, 128. So in this case, the last bit that is turned on, 8 is the decimal value. So 8 is the network increment. So the next step is to find the 0 network and then incrementing by 8 to get to these IP addresses, which earlier we talked about. The 0 network, we just need to apply the default subnet mask. And for the host portion of the default subnet mask, we put 0. We just keep the network portion. So this is class B. How do we know? Looking at the first octet, 172 falls into class B, and the default subnet mask for class B is 255.255.0.0, right? So the first octet we keep and the second octet we keep to find out the first subnet, to find out the 0 network, and then be able to continue incrementing by 8, our increment ID. The last bit turned on, that's looking at the decimal value, that's the network increment ID. Okay, so let's rewrite our 0 network. Let's erase all this. It is 172.16.0.0. Let's continue incrementing by 8 on the third octet, right? So 172.16.8.0. 0. And if we continue incrementing, we should get to 40.0, and the next one 48.0. And looking on the third octet, here we can see 43, 44, 45, 46, 47. Here we can see a range 40 to 48. It covers all this. So this subnet, the 172.16.40.0 with the CIDR notation of 21, it covers all these addresses. Therefore, in a routing table, if we have the network address of 172.16.40.0, with the CIDR notation of 21 or the subnet mask of 255.255.248.0. You might say where this 248 is coming from. I'm just converting this binary for the subnet mask into the decimal format. So the binary of 8 bits, that's 255, 8 bits on a second octet 255. The third octet we have only 5 bits turned on, and when we convert this binary to decimal is 248, and then on the last octet 8 bits of 0, which the decimal value is 0. So this network address and this subnet mask covers all these addresses. And again, how do we know this subnet? Because looking at the third octet 40, all these addresses falls into the third octet, because the next subnet would be 172.16.48.0, right? If we are incrementing by 8 here. So instead of having 1, 2, 3, 4, 5 different network addresses in a routing table, we can have this one network address with this new subnet mask address in the routing table, which basically advertises all these addresses and covers all these network addresses. So we can apply supernetting on the network addresses with the fixed prefix CIDR notation. We can combine contiguous networks that all have common CIDR prefix. In this case 43, 44, 45, 46, 47, that's all contiguous and the same CIDR prefix. What was the first step? Writing down the octets that are not the same, converting into the binary, and then counting how many bits are exactly the same on all of them, and then draw a cut line after that, all zeros. That will be our new subnet mask. Or we can see the CIDR notation, in this case 21. If we count all the ones, that's 21 ones, which again, this will give us the subnet mask of 255.255.248.0. And then to find this actual subnet, we have to start from the 0 subnet and then keep incrementing by the increment ID, which we talked about, the last bit turned on. Decimal value is the increment ID, in this case 8, on the third octet. So writing down the 0 network or the first subnet and then keep incrementing by 8 till we get to the subnet that can cover all these addresses. So because the cut line on the third octet and the increment is 8, on the third octet we are keep incrementing by 8. Till when we get to the 40, we know after that is 48. So the subnet with 172.16.40.0 can cover all these addresses. And this will be our new CIDR notation. Therefore, this address with this subnet mask covers all this. And this was an example of supernetting, or IP address aggregation, or route summarization. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.